Hello, dear students. Welcome to the channel and very welcome to this playlist in which we are discussing 8085 microprocessor. Up till now, we have discussed about the architecture, pin diagram, and different type of configurations of 8085 microprocessor with different devices used in it. And today we are going to start the programming part of 8085 microprocessor. So we all know that we can do the programming in 8085, right? It is capable for performing few operations at very high speed, and its instruction set has some indication towards us, right? Like the ALU in combination with the different registers can be controlled by binary operation codes to perform arithmetic operations. Then this microprocessor can transfer data inside the CPU, and it can perform logical and arithmetic manipulators. Then microprocessor can make decision based on the manipulated results, and it can also move data into and out of the microprocessor as well. But it cannot do it all by itself. It cannot perform any simple calculation or data transfer by itself. It must be told in clear terms, in complete detail, just what to do and what order, what order it has to do, right? So the physical components, the connections and logical circuits that take part in decoding and execution of the operational codes constitutes the computer hardware, everything. Then the list of specific details, instructions selected from those allowed by microprocessor manufacturer and organized to control operations constitutes computer software. So now let's see what are the steps in programming of 8085. First step is defining the problem to be solved, right? The problem for which you are preparing the program, the different terms must be clearly mentioned, like what are the inputs of your program, right? It can have different inputs, like it can have directly data available. Then the data can be stored in some general purpose register and you have to fetch it, or the data is stored in memory location and then you have to fetch it. So the input must be clearly specified in different conditions. Then second is what is the operation you are expecting, right? The operation you want to perform or on the input data must be very clear, right? It must be very much clear. And third is, where do you want your output, right? You have specified the input operation, but where do you want to store the result? You have to do it as well. Second step is solution plan. So to perform operations specified in definition, the plan to solve the problem should be prepared, and it includes some different points, like in what form you are taking your data, the input, and which method are you using to reach to the solution of the problem, and what are the steps of that method, right? And how will you output the result, like how will you display your how are you planning to display your result. Then you have to draw a flowchart is a pictorial representation of different actions and computations that are taken to perform any task, right? It's pretty much similar to block diagram. I think you can find it. You can find the flowchart very easily, and you must have seen that arrow is indicates the direction of flow. Then we have parallelogram for input output, we have rectangle for the process operation, we have the diamond for the decision unit or conditional statements, oval is for start and stop unit, and circles with an arrow to represent the flow of my diagram, right? So what is the function of flowchart? Flowchart breaks the large and complex programs into a smaller logical units and makes it easier to make the changes and the corrections. Next one is the program. So programming is something that you are putting the instruction instead of the flowchart blocks, right? So first you divided your big task in small steps using flowchart, and now you are writing a program and putting it in microcontroller. And then the final step is checking the results. You check the results of your program. Then we have the different formats of the instruction, right? So instruction is a binary pattern designed inside a processor to perform specific functions. And when you take the entire group of the instructions, you called it instruction set, right? And that instruction set determines what function that microprocessor can perform, right? So each instruction basically contains two parts. First part is opcode and second part is operand. So opcode part of the instruction specifies the operation to be performed. What operation I want to perform is specified by opcode, and operand either provides the data or specifies the data, right? And operand can be specified in a number of ways, right? It can include 8-bit by 16-bit internal general purpose register, or a memory location, or any memory address, 8-bit or 16-bit, any memory address, right? Or even it can be an implicit operand, which means the operand is not specified. Instead, it is assumed in some register. And depending on number of bytes or bits patterns required to specify operation and data, the instruction set are divided in three types: 1 byte, 2 byte, and 3 byte. uh, and in 1 byte, the instruction includes opcode and operand in the 8-bit only, right? Like single byte. And the 1 byte instruction specifies the operation to be performed and who is going to perform. Simple, nothing else, just operation to be performed and who is going to perform. So it is in opcode format, because of course we are having only 8 bytes, so there will be no other operation or instruction except for the opcode. And when we go for a 2 byte, we go for 16 bits, and we get opcode and operand both together. Then we have the addressing modes. Various formats for specifying operations are called addressing modes, right? And there are multiple formats, like mentioned here. We have five mentioned here. The first one is the immediate address mode or immediate addressing mode. So in this addressing mode, the data, which is 8 by 16 bit 8 or 16 bit, is specified in the instruction set itself. And immediate addressing instructions are either 2 byte or 3 byte long, right? In 2 byte instruction, first byte of the instruction is opcode, and second byte is some 8-bit data. And in 3 byte instruction set, first byte is opcode, second and third byte are 16-bit data, right? When we go for 2 byte, the second byte is 8-bit data, and in 3 byte, second and third both are 8 bits, so total 16-bit data. And the instruction containing the letter I indicates the immediate addressing mode, right? So when I say MVI A comma 10H, means the instruction transfers immediate data, which is A0H, to my register A, right? Then we have the register addressing mode. This mode is the source and destination. This mode, the source and the destination operands are general purpose registers, and register addressing instructions are generally of 1 byte only. opcode only, because it has to work with only registers, right? So opcode specifies the operation and register to be used to perform the operation. Simple like move D to B, or move D to C, or add A, like that. The move D to B instruction copies the content of register B to register D, and the source and the destination operands are both registers. Simple. We will learn about this in detail. Then we have the add B, which is the instruction that adds the contents of B register to A register, and then the data is present in both B and A register at the same time, right? And the result will be stored in the accumulator. Result is always stored in the accumulator. Always remember that. Then with the direct addressing mode, in direct addressing mode, the 16-bit address of operand is given with the instruction itself. So the instruction in the direct addressing mode are generally 3-byte instruction. First byte is opcode again, second is lower order address byte, and third is the higher order address byte. So when I say STA D200H, which means STA stored accumulator directly to the memory location, right? So in this instruction, what will happen? The content of accumulator will be stored to the memory location D200H. Then we have the indirect addressing mode. So in this mode, the instructions reference the memory through the register pair. So memory address where the operand is located is specified by the contents of the register pair. Like move a comma M. In this case, what happens? The M is the memory pointer specifying any HL register pair where the address is stored, and the content of this HL pair are used as an address, and the content that memory location are transferred to accumulator. Then we have the implied addressing and implicit addressing mode. The implied mode of addressing does not require any operand, and the data is specified within the opcode itself. So generally, the implying addressing mode instruction is the 1-byte instruction, and the data is supposed to be present generally in accumulator itself. Like RAL, which is a rotate accumulator left instruction, it operates on data in accumulator only. So whenever RAL is used, it is implied that the data to be operated on is available in accumulator only. But this is very rare instruction. We don't use it often. Now let's move forward. Now let's come to the different addressing sets of 8085. So instructions are generally classified into the functional categories like data transfer group, arithmetic group, logical group, branching, stack and machine control group, right? And we have different notations which we used for different instructions. Like we use M for the memory location pointed by HL register pair. We use R for the 8-bit register, R for capital R for 16-bit register, RP exactly for 16-bit register pair, RS for the source register, RD for the destination register. We use add R for 16-bit address, and we use data for 8-bit data, and data 16-bit for 16-bit data. Now let's discuss about all these groups one by one. First one is the data transfer group, and I think today we would only be able to discuss data transfer because we will be discussing some of the cases and instructions of data transfer group as well. So data transfer group of instructions is a group of instructions that copies the data from source to destination without modifying the contents of the source, right? And different type of data transfers are possible between direct data or registers and memory locations. Like we can transfer the data between two registers, like register B to register D, register C to register B, register C to register D. Anyways, then we can do a specific data byte to register or a memory location, like we can send the data from data byte to register B. Data transfer can take place between two different memory locations and registers as well, like particular memory location to register A or particular memory location to register B. And it can also take place between input output device and the accumulator, like any input device to accumulator. And we can do it between the register pair and the stack as well, right? So register pair data can also be transferred to the stack location. Now let's discuss some of the instructions. So first instruction is mvi r comma data, right? That's its mnemonic. And algorithm means it is indicating the transfer of the data. So data is getting transferred to some memory location r, which means some data is getting transferred to the memory location r, which means data, the content in the data is getting written in the r, right? So instruction moves the immediate 8-bit data to register specified in the instruction, and it is a 2-byte instruction where the first byte of instruction is the opcode and the second byte is 8-bit data that's specified in the instruction. The register r can be any 8-bit general purpose register like A, B, C, D, E, H, L, any of those. It is a 2-byte register. First byte is opcode, second byte is 8-bit data, clear. And it is following immediate addressing mode. Most of the instructions we are going to discuss today will be following either immediate instruction mode or any of the modes which we have discussed today, right? We have discussed 5: immediate, register, direct, indirect, and implied. So it's following immediate, and it's not affecting any flags. I will discuss with you whenever we will get the flag affected instruction, or the instruction that affects the flag. And what is the example? Example is mvi c comma ath is some address or memory location, and it is transferring the data to the register C, right? So here you can see before execution, these are the register pairs, all the register pairs. See, A, F, D, B, H, E, L, L, all these are empty. Stack pointer, program counter are also empty. And at C we have some some data or some opcode AA. And then what is happening after execution? This data is getting transferred to the register C. We are getting 80 in the register C. So 80H is getting printed at register C. So that's what mvi r comma data do. Then again we have mvi mi comma data or m comma data. So what is it doing? It is transferring the data to m or to some memory location, right? Previously what did we had? We had some register, but here what is happening? We are transferring some data at memory location, right? And again we are following immediate addressing mode, right? So this instruction moves the immediate data to memory, and we can pick immediate data on our own. So here we have picked 25, right? And it allows us to print the data in HL register pair, because HL register pair is used as a memory pointer here, and the content of HL register pair are used as the memory address, and the immediate data is transferred to the memory location. Now as it is a 2-byte instruction, first byte will be opcode and other byte would be 8-bit data. And again no flags are being affected, no flags are modified here. So what would be the instruction? Let's say mvi m comma 25. So let's say H has 42H and L has 25H, right? So the instruction will store the data 25H in the memory location addressed by HL pair, right? So it will store 25H in, see what does H do? H indicates two higher bytes, two higher bits, and L lower bits, right? So sorry, lower bytes and higher bytes, sorry. So what does it do? See, first 42 is stored before execution, 42 is in H, so H is indicating 42, L is indicating 25. Immediate data we have is 25, which we have selected here from here. And where do we have to point? 4225 location, right? So what does the 4225 have before the execution? It has 10. But now what do we have to do? We have to put this 25 into 4225. So see, after execution the 25 will be put in the 4225 location, right? The third one is move R to R, right? If we even if you don't want to discuss the D and S written over here, it would be okay. The basic is we are moving uh, content of register S to register D. S for source, D for destination, and operation would be RD is equals to RS, because we are moving the same content, all of the content of register S to all of the to register D, which would be whatever instruction it would have, it would be replaced. So it copies the data from source register to destination, and source of the destination can be any general purpose register. It can be A, B, C, D, E, H, L, any of that. And the content of the source register will remain unchanged, but the destination register will be changed. And it holds only one byte, right? Opcode of mov rd comma rs, it's a move instruction, and it is a register addressing mode. Notice the register mode has changed, addressing mode has been changed, because previously what we were doing, we did had them some immediate value, right? Immediate instruction. But here what are we doing? We are just simply moving the data or content of register S to register D, or register RS to RD, sorry, or some, let's say, B to A, right? And always remember, the source would be on the right hand side and destination would be on the left hand side. So you can remember this way as well, for not only for this but for every instruction. See, source, destination, source, destination, right? Everywhere. So it also again does not affect any flags. And this is the register addressing mode, because the data transfer is taking place between two registers. The instruction mov a comma b copies the content of register B to the register A. Let's suppose A has 25H and B has 59H. So after getting instruction, see, A has 25 and B has 59. After we execute this move A comma B, which you can pronounce move B to A will also have the same content as B, and see, the content of B is totally unchanged, but content of A has been changed, right? So that's the instruction. Then we have move M comma R, or move R to M. And again, what does it do? It copies or moves the data or content of some R register to some memory location M, right? So it copies data from register R to memory M. The HL register pair is used as a memory pointer, and content of HL register pair are used as memory address, and the content of specified register are transferred to that memory location. The register R can be any 8-bit general purpose register like A, B, C, D, E, H, L, anything, and it consumes only 1 byte, right? And it is operating in indirect addressing mode again, because we are moving to some memory location, right? So again, no flags are being affected here. But Let's say the content of HL register pair is as you can see here 5015, and the content of the register C is 1A as you can see. Then after the execution of instruction M, move M comma C, the content of register C, which is 1A, will be stored, uh, will be copied would be the right word, copied to the memory location pointed by the HL register pair. What is the memory location? 5015. Higher bits 50, lower bit 15. So 5015 will 1A will be copied to this memory location 5015H. The next instruction is move R comma M. Uh, this instruction copies the data from memory M to register R, and the content of HL register pair are used as an address of the memory location. So the content of the memory location pointed by HL register pair will be transferred to the specified register. Simple, same as what we are doing for some time now. And again, it's a 1 byte instruction. No flags are being affected in this instruction, and it is operating in the direct addressing mode because we are directly pointing out the address. For example, let's say take instruction move C comma M as indicated here, which means content of HL register pair, which you can see here we have 5015 again and 1A stored in the C one more time, and what memory location it is indicating. Now it should be clear, it is indicating 5015. So 5015, earlier it had earlier it had some memory 10, and now what we are doing, so we are taking the content of 5015 which is pointed by this HL register to my, to which register? Register C. So see, register C is now has 10. Earlier it had 1A but it got erased, and the content of 5015 memory address has been copied to my register C, right? So that was move R comma M, and the final one is the STA address. So this instruction copies the content of the accumulator to some memory location whose address is specified in the instruction. And this is a 3 byte instruction. First byte is the opcode, second byte would be the lower order byte of the address, and third byte would be the higher order byte of the address. And it's also again operating in the direct addressing mode. No flags are being affected. So for an example, we have we are considering STA 5027, memory address 5027, and accumulator is having 12 as the content inside it. Before we execute the instruction, so what it will do, the instruction will load the content of accumulator, which is, what is it, 12 or 12H you can say, to the memory location which is specified in the instruction, right? What is the memory location specified in the instruction? See, 5027H. So it will load the content 12 to 5027H memory location. So that you can see here, this, see, 5027, what did it had earlier? It had 10 before execution. After execution, 5027 will have 12 here. And um, one more interesting thing, that it is not getting pointed by HL register here. See, earlier we used to point everything using HL register, but when we have STA, we are directly sending the content of accumulator to the address which is pointed by this um, direct address of memory location, right? So 50 are higher order bytes of address, and 27 lower order bytes of address, and it is getting stored at 5027. And that would be our final instruction for today. and we will be continuing tomorrow with some other programs. Please give me feedback. How do you like these classes? If it needs some improvement, or if you want me to make videos on any other content or topics, feel free to mention that. Also, please ask doubts. You people are not asking doubts. Please mention your doubts in the comment section, so I can understand how much you have understood, and then we can enhance that knowledge, right? We can, and if you have understood enough, then we can go to the practicals. So that's it for today. We'll keep today's class here. Till now, I'll be seeing you next time. Thank you very much for listening, and goodbye for now.